we prepared this list of questions with Dotphoton's team. So some of the questions come from myself, and some questions come from people who are genuinely interested in the field. And but the very first question, would be, how would you describe what light sheet microscopy is, and why what's the benefit of it to a person who doesn't know? Once I saw it trying to be explained in one conference, and to be honest, the majority of people left this talk, without without clue actually what this is about. And we're discussing, when the human brains can be photographed. That was a discussion for the listeners of this talk. So, how would you describe it?
Yes, well, hopefully nobody leaves the room and is very confused after I explain this. I think the easiest way to explain light sheet microscopy, just at a very general level, is that it allows you to see things at scale that was not possible with previous microscopy techniques. And that is mainly due to the speed that light sheet microscopy is able to provide. And so if we dig a layer deeper, how does light sheet microscopy go so quickly? More traditional microscopy methods typically produced high quality images point by point. And so they would raster scan a point across the sample. And light sheet microscopy, by using a sheet of light to excite the sample and making that coplanar with the focal plane of the imaging objective, basically means that you can collect whole 2D images now. And so what that means is you're not capturing just one pixel at a time and kind of moving through the sample, but you're actually capturing a whole plane of, say 4 million pixels all at once. And so that's really where the speed difference comes from. And I think the ideas of light sheet microscopy had maybe been around for decades, but actually the technology was not there to enable it. And so once scientific CMOS cameras kind of became more mainstream, more affordable, I think that really is when light sheet microscopy was able to take off and explode. And so in most recent light sheet systems, the speed is in many cases just limited by how fast can the camera take pictures, how fast can you snap those 2D images. And so it's a tremendously exciting type of microscopy, and it's kind of broken up into two camps. One camp looks at live specimens, and so in that case, the speed is very advantageous because you can do high-speed 3D imaging of living embryos, for example. And then the other camp, more where I have been, is if you have a dead fixed tissue, but how quickly can you just move your way through this large tissue? And there again, the speed is really helpful. And so I'm sure new applications of light sheet microscopy will continue to pop up, and they're all really based on that speed factor which it provides.
Mm-hmm. And well, it brings us to the next question. I think it's, well, when I went through the list of your publications, but in general as well, following for the last, I think, 4 years, light sheet microscopy conferences and all kind of public talks, you could see how it becomes less and less purely research, purely fundamental, and how there are real case scenarios, or for example, linked to drug development or cancer research, start to appear in the light sheet microscopy. Is it the general trend, or is it just one camp, and that's how it will be, and the other part will always be purely research? How do you feel how it's going to change, and how it's going to be linked to the real life scenarios?
Yeah, no, that is a great question. I think that there'll always be both sides, and so say within optics and microscopy, where I've been working for several years now, it's important to have the fundamental research into discovering new ways of doing microscopy, and in light sheet microscopy in particular. There is this kind of core technology, this core idea of how you set up a light sheet system, but it's such a hot and active field that every month, maybe even every other week, there's new tricks either on the hardware side, the software side, or both, that are really, really interesting. And so many of those papers just prove out the point that we can do this much faster, we can see something this much smaller. But then on the applicational side, and I've been working, I'd say more on the applicational side, you can kind of look at this tool belt of tricks that people have come up with and kind of pick what is going to be most useful to achieve your end goal for your application. And so myself specifically, several years ago when I joined the University of Washington, I joined the lab of John Liu, and he and a pathology resident had this idea of, can we use some sort of microscopy, maybe not light sheet, to address this clinical pathology question. And as we researched the methods that are out there, we determined light sheet microscopy was a great fit because of the speed. And then our innovations, or what we've tried to do in this field, is to adapt light sheet microscopy to be compatible with clinical pathology, with clinical workflows. And that kind of goes back to looking at that tool belt of tricks. How have people set up these microscopes that in a way which could be compatible? What resolution do we need, what, etc. So I think both kind of feed back and forth. And then if there's a clinical need or a life sciences need, it can help motivate a fundamental scientist to come up with a trick. So I think I'd hope that it's this sort of cyclical feedback loop that drives innovation on both sides.
Yeah, but do you think, it's a little bit out of scope, but it's the continuing question. Do you think that such innovation is today scalable to the real life scenarios? I can explain where this example comes from, this question comes from. We do work with high throughput screening applications and digital pathology applications too. And we recently calculated, we took a very well-funded hospital in Europe, and we realized that they have 5,000 cancer patients per year. And then we realized, because probably, I'm sure you hear a lot about how AI is great to diagnose, to help doctors to diagnose, for example, rare cases of cancer. And we realized if we really do it properly and keep all the data as we should, train algorithms and so on, the hospital will be able to keep only 125 patients per year. So basically the solutions which were already available today, they're not at all scalable for real life scenarios. Do you think it's linked to light sheet microscopy too? And what would be the biggest obstacle to overcome to become such a solution which can be in hospital environment?
Yes, yeah, that's a fantastic question. I can say, yes, scaling it out at a clinical level. I'll back up and just say at the academic level in our laboratory, just over the last few years, there's one elephant in the room which has really been an issue, and that is the data. So the data is this beast with light sheet microscopy that you have to wrangle at all levels. The first stage is just how do you ingest the data off of these cameras, because light sheet microscopy tends to run one or sometimes more of these cameras full blast for hours, even days. And so the question is, how do you move that data around? How do you store it? How do you process it? And so when trying to think about how to move light sheet microscopy to clinical pathology, I think we're there on the hardware and say the specimen prep. Regulatory approval is maybe a different thing to tackle, but the data is where a lot of the work has to be done. And so I think moving the data to the cloud is one thing we've been exploring within our startup company. And so that makes things a little bit more feasible, I'd say, but still the storage of the data and actually just moving the data to the cloud can actually become a bottleneck. And so there, just the sheer size of the data is something that needs to be addressed.
But do you think the cloud will be definitely the way, where things linked to the big image data will move?
I think at a clinical level, I think the cloud would be the place to go, although there could be regulatory approval issues, so that would have to be worked out. But we are grappling with this on-prem versus in the cloud issue right now of, do we keep the data in our storage servers locally, or do we actually just scale out to the cloud? And I think there the cost analysis is what will determine what ends up being the most feasible path forward. And I think not to get too detailed, but two really important things there are, can we make the data smaller so that it's cheaper to store? And then secondly, if it is made smaller, what is the necessary means to uncompress it, say we compress the data? And so we've been doing something which requires a GPU that is, I would say, not as feasible in the cloud because it is extremely expensive to use GPUs. And so being able to move away from that, not to get too detailed, but I think that's very important.
Yeah, I see. Yeah, so, well, obviously we are exposed to this problem on our daily basis. That's our routine in our lives. So it's, well, I personally think it's true that it's moving towards the cloud. There are still so many a lot of people think about data storage, big data storage for such applications, like they think about the iPhone photo storage. I think, well, that's easy, that's cheap, it's affordable, it costs nothing, but actually they don't understand the scale of it for sure. And I remember we needed once to get the light sheet microscope images from Geneva, which is in Switzerland, and we really needed to travel there because there was no even way, not a single way how we could transfer this relatively small data set actually for light sheet microscopy to our servers. So yeah, well, I'm glad that we with JetRaw and Dotphoton we're trying to approach this problem. I hope we won't probably be able to solve it, but we'll find a solution which will allow researchers to get the job done faster, and really unlock the power of raw images, because they must be raw, right? They must be of the highest quality. At the same time, magically they have to become faster and smaller. So, and that's my thing. A colleague of mine, again, she looked at the name of the articles, in the Nature publications of yours, which are, well, obviously, but I cannot say probably all scientists dream, but a lot of scientists dream about, published in Nature and these great research magazines. And she asked, how do you think one can maximize chances of a discovery, of an interesting discovery that will really, will affect somehow the professional world of this particular science field, and what elements are to be present there?
That's a very, very good question. I think my experience at the University of Washington can really speak to that one. And I think for me personally, with this whole project in light sheet microscopy that has kind of been born out of our team at the University of Washington. So I think no one person has all of the expertise to do everything. And so in order to maximize impact, you really need to have different key components in a team that allow things to be successful. And I think we've had exactly that at the University of Washington, which has allowed us to, I think, hopefully start to really drive this application and this technology. And so that has involved myself arriving as a postdoc, someone who had technical engineering skills and was looking for a project to work on. But really within the clinical space, having clinicians on board and working with you, because the clinicians actually have the issues, the challenges, the problems that they want solved. It's almost like the customer in some ways. And so we worked directly with Nick Reeder, who's actually he was a resident at the time and had this idea of, hey, I want to transform pathology. And then his supervisor, Dr. True, having them both as key members was extremely important. And then, of course, John Liu, my advisor, to advise the technical side of things. And so I think for any application to maximize the impact, you need to have like a very important team of people, and specifically within clinical applications, you need to have clinicians on board. And so
it links actually science to the startup, because I think like they tried to discover what the successful startups are. Are they about the idea? And they said it's not actually, it's only partially about the idea. It's a lot about the team, So does it ring a bell for you? That this team is important as the idea? Is it the case for scientific discoveries too, do you think?
I definitely think so. That on their own, each team member may be brilliant, but if they cannot work well together, then projects can stall, projects can veer in the wrong direction. And so I think, yes, the team is extremely important, and there's synergy, there's chemistry there, and I think we've been really lucky to have that in our work over the last few years, and hope that will continue into the future. And I hope that for whatever future pursuits I kind of bite off, I hope that there's that same sort of experience, because it's been a blast these last few years working with everybody with our team here.
That's great to hear. Well, and then thank you very much. That's very interesting and very inspiring, because, well, I think, sometimes people really rely on the idea, and I do as well advocate for the power of team first and then the idea second, because I think with a great team, you can always invent things, even if the original idea was not that great. And then we have this one very special question that we ask everyone, because as I said, we started this whole series of interviews, which we called Houston. We have a question, not a problem, and we started it because we are surrounded by very interesting people, and it's very interesting as well how these people look at the future. And the question sounds like this: if you could pick up one word to describe which will define the society in the next few years, what this word would be for you?
Oh, interesting. One word. I would think that, you know, maybe it's in my mind because of what we just mentioned, but I would say teamwork, or teamwork at a global level. I mean, I think that COVID-19 has really highlighted this of it's an issue which faces society, which crosses borders, crosses cultures, crosses economic, status, and so we have had to work together. Well, there are still issues around how COVID has been addressed at some of these different levels, but by and large, we have worked together, I think, as states, countries, like humans, to address this problem. And I think that we are making good progress, and hopefully we are able to beat it. But I think we were lucky with COVID-19 in that it wasn't as severe as some of the scientists said it could have been. But when we look to the future towards things like climate change has been something which needs the same sort of teamwork to really address. And unfortunately, something like COVID is so in your face that it kind of demands an immediate response, whereas climate change does not. There's other, global issues which we've faced for a long time, and I think we just have not been serious about addressing at a really rapid pace. And so I think, in my mind, defining society moving forward is really these global issues, and how can we work together as a team, as a planet, to address them. And that's extremely challenging, probably the most difficult scientific and also just social issues to address. But I would like to think that those are areas where we make rapid strides, especially learning after this COVID-19 experience.
Well, that's very inspiring, and well, I totally agree with you here, because the problems are not local anymore, or not that local anymore, and we really must learn how to work together and bypass some of the contradictory opinions sometimes we have, in order to to make the life of this planet a little bit better.
Yes,
Yeah.
definitely.
Well, thank you very much, Adam. It was a pleasure to have this interview, and thank you very much for your answers. And yeah, I'm very glad actually to meet you personally, although in this format, because I heard so much about you from the team, and now it's really my pleasure to talk to you.
Oh, thank you so much, and yeah, thank you for your support and everything that you're doing as well. I think I've been engaged with Michael and the other team members, and now you, because I think the work you're doing is very